All right, let's go ahead and talk about section 4.3. In section 4.3, we're talking about graphing using intercepts. When we talk about intercepts, in mathematics, we're talking about where graphs cross either the x-axis or the y-axis, and we call them the x-intercept and the y-intercept. So I know your picture doesn't have the same line drawn in that I have, so take a rough guess. And what I really want you to notice is that in my graph, I made this line cross the x-axis at -2. So in this case, we're just simply going to look at it, and we're going to say that the x-intercept is equal to -2 in this problem. When we go to the one down below, the y-intercept, remember we're just looking for the y value of the point. So that when we look at the y-axis, that's up here, that's where my line crosses the y-axis, and I made on this particular graph my y-intercept, I made it be +3. It doesn't matter about anything else with the line. We're just looking at where does it cross the y-axis. Now these 2 points work together in most problems to generate a single line, as opposed to our picture where we made 2 lines. So I want to remind you that we talked about the fact that that point that I put in was the point -2, 0, because by definition an x-intercept is in fact a point, and we're looking at the x value for that point of being -2. Notice that for every x-intercept, the y value is 0. I'm going to write that down. For every x-intercept, the y value is 0. Now we can make a similar statement for y-intercepts. Remember, that's the point where the graph crosses the y-axis. So all of the points on the y-axis have an x value of 0. So I'm going to write down for every y-intercept, the x value of the ordered pair is 0. Okay, now what are we going to do with this? Well, we're really going to graph lines. The first is, we'll algebraically find the x-intercept and find the y-intercept without actually drawing the graph. These are the pretty easy problems. It used that statement that we just wrote down. To find an x-intercept, we need to make y be 0. So I usually label mine, so I know what I'm looking for, x-intercept. So I'm going to make y be equal to 0, which just means plug in a 0 in the y spot. We know that anything times 0 is 0, so this really says 3x minus 0. So 3x is equal to 6. Divide both sides by 3, and we get the fact that the x-intercept is at +2. We could do lots of things with that. Similarly, when we look at the y-intercept, and I always label my work so I know what I'm looking for, we say, okay, we're looking for the y-intercept. We need a number in that y spot, and we want the x part to be 0. So plug in a 0 for x. 3 times 0 minus 2y is equal to 6. We now have 3 times 0, 0, minus 2y, so -2y is equal to 6. It's a one-step equation. Divide both sides by -2. Y is equal to -3. So we could just be asked algebraically to find those two pieces, x-intercept, y-intercept. In example 2, you're asked to find them algebraically and then graph them. Do the algebraically part without me. So pause it. Hopefully those two felt very obvious to you. The second part of this is that we have to use these two values to plot a graph. Remember, an x-intercept is the point 4, 0, or the point on the x-axis. So we're going to positive 4 on the x-axis. And we also need to go to positive 2 on the y-axis, because that's the point 0, 2. So we go to 2, positive 2 on the y-axis. We've graphed 2 points, and that's enough for us to be able to sketch a line. Now I know some of you are going to want to do this and just connect the dots. Remember, our graph should go edge to edge, and we should be using a straight edge so you don't end up with wiggly worms like I have. No wiggly worms, straight edges. Let's go down to example 3. In example 3, given the graph of an equation, identify the x-intercept and the y-intercept. I think I may have forgotten to put the line in on your graph, so make sure that you take a second and copy this picture. And I can see that my line crosses here on the x-axis and crosses here on the y-axis. So, and I sat still too long again. 1 second. See, that's what you guys do in my classroom all day. Keep the lights on. All right. So we have that x-intercept. Oops, x-intercept. That's a dash. Is at -3. And my y-intercept is at -5. If you listed those as points, that would be okay as well. Or if they forced you to use points, make sure you're ready for that too. The x-intercept has an x value of a number and a y value of 0. A y-intercept means that that -5 should go in the y spot of the coordinates, and a 0 goes in for x. 2 separate points. I think in example 4, I'm pretty confident that you'll be okay in the first example, and we need to talk about the second one. So pause the video, try this first part, or 4A, and then come back and listen for 4B. Like I said, section 4 is a relatively easy section, so make sure that you've graphed this properly, that you have your -3s on the x-axis, -4 on the y-axis. Let's go to the second problem though. An x-intercept at +2, so we're on the x-axis and I need a point at +2, and there's no y-intercept. That tells you that the graph never touches the y-axis. The only way that it could never touch the y-axis was if it were parallel to the y-axis. It's the only way that could happen. If it was slanted either way, sloped either way, then it would eventually touch the y-axis. We don't want it to ever touch, so we should have drawn a vertical line. Now the real purpose to x-intercepts and y-intercepts is actually in our story problems. Let's read this one together. It says, story problems, because I love story problems. What's the meaning of an intercept when you have a story problem? Usually when we have these, we're going to be talking about having 2 types of things, whether it's, price A and price B, or table 1, table 2. There's going to be 2 different things that are going to be very obvious. And the meaning of an intercept is what if your total was composed of all one thing? Or what if your total is composed of all the other thing? I'm not sure exactly how to write that down so it makes sense to you, but take a moment and write it down. And if we're having trouble with that meaning of a story problem, maybe you want to come back. I think what I'm going to do is I'm going to come back and write it in after I've done the problem below. So, pause and write if you're ready. Otherwise, let's move forward. As a member of the Student Association, you're asked to be part of the prom planning for this spring. The location has already been chosen and they have 2 types of tables that you can put into the room. The first type will seat 8 people, an 8 top, and the second type will seat 10 people, 10 top. You need to have enough seats for 320 people. So if we think about this, we could split them up. Some people at 8 tops and some people at 10 tops. But how many people go with each kind? We are officially allowed to use more than one variable. So that remember, our first step is always define those variables. If I let x equal the number of 8 top tables, and I let y be the number of 10 top tables, then I can write the equation 8 people times however many tables I need plus 10 people times however many 10 tops I have has to equal 320 people. Well, more than 320 people go to prom, but it was a good number and it made a pretty problem. So what the meaning of the intercepts are is, what if I only have 8 tops? How many tables would I need? So my x-intercept, what if I only have 8 tops? 8x plus 10 times 0, so I don't want to have any 10 tops. And I still have to seat those 320 people. So that means that 8x is equal to 320. Divide both sides by 8. And we get x is equal to 40. So I would have to have enough room to put 40 tables into that room. In contrast, what if I didn't put any 8 tops and I only used 10 tops? That's my y-intercept. No 8 tops. Plus how many 10 tops? Right? 10 people for every table. That's what y stands for, number of tables that seat 10 people, so that I get 320 people seated. So 10y is equal to 320. Divide both sides by 10 so that y is equal to 32. Those are my two intercepts.